We're going to now talk about CFM 56 LEAP engine. How does it operate? Very simplified. We have down here is a fan, and basically that will be rotating. And then we have the inlet guide vanes down here, and this is a bypass. Basically, the inner core will go through inlet guide vanes to the high pressure compressors, and then to the combustion chamber, and then to the turbine, and then exhaust. Now here we have sensing the pressure. It's basically down here. This will go for checking the pressure down here. It goes to this box. Basically, it's got the pressure transducers, and this feeds the system about the pressure, air pressure, temperature, air pressure data. It will be supplied to EEC, plus high pressure compressor and EGT. All this information will go to the EEC. This is the box basically, which is electronic engine control unit, channel A, channel B. Basically, if one fails, the other channel will be controlling the system, and this is automatically will control the thrust of the engine, and it takes all the parameters into conditions. Now, when EEC needs to be replaced, then we have to do software loading. As you can see down here, it comes here to this plug, where we have to disconnect. Then we basically use the portable data loader, and then from here we'll basically do software loading. This software basically, it will inform the ECU, electronic control unit, what type of engine has got, what is his maximum thrust limit it is, and all other parameters which is required for the computer to know. And then the data information software will be transferred to this channel down there. So channel A, channel B. Then we have a pneumatic system. The pneumatic system, to start the engine, air from the APU will come down here, and it will go to the starter valve. This is air starter valve. We're using air, and it basically, there is a turbine. It will rotate, and this is attached to the gearbox. And the gearbox, basically, it will rotate basically the compressor, and the compressor basically, when it's working, it will the fan and the turbine, they will rotate, and the air gets compressed. It goes to the combustion chamber, and the fuel air mixture gets ignited, and then through LP turbine and HP turbine, and then exhaust. Now, this is basically the LP turbine. It gets extremely hot. It can reaches to 8 to 1000 degrees Celsius maybe. This is HP casing also, and we can see down here, because the exhaust portion of it has been removed. Now, because it gets heat, it expands, so we need to cool it. So there is a system to cool it in order to increase the efficiency of the engine. And you can see these tubes is basically gas air. This is for low pressure active control turbine cooling system. Basically, it gets it from the cooling air from the compressor. It will be taken, and it goes to this valve. This valve is operated, believe it or not, this valve is operated by the fuel, and this is also controlled by the ECU, electronic engine control unit. One for channel A. If it fails, then you have channel B will be controlling. Now it will look at the temperature of the EGT and the temperature of the turbine, and consequently it will regulate the correct amount. It comes down here to these tubes down here, and this will be a cooler air, basically to cool the low pressure turbine casing. Now, as I said, to increase the efficiency of the engine. And also this one is for high pressure turbine casing cooling. Now, high pressure turbine case cooling, it comes also, this is fuel operated, and this is controlled by the ECU, electronic engine control unit. It goes down there, and we can go and see. Basically it comes down here. It comes down here. From there it comes down here. This is for high pressure turbine cooling. It comes down here. So basically it will cool the high pressure turbine down here, this one here. So the cold air comes down here to cool the high pressure turbine casing, to prevent expansion of the turbine, and to minimize engine thrust. So this is all the part of the thrust management, basically. So we have high pressure turbine cooling. This is controlled automatically by the ECU, as you can see down here, there, and it will cool basically high pressure turbine casing. This is for low pressure turbine casing, and you can see down here, from there you can get the cold air is coming to cool this low pressure casing, yeah, because it gets expansion with the heat, and it causes reduction in heat. And these are the sensors here. This is fire loop detection system. If there is a fire, it will detect fire or overheat, and then it gives appropriate warning to the system. Now, that basically about the thrust management of the CFM 56 LEAP engine. We have the fuel system. The fuel from the tanks will come from low pressure booster pumps. Low pressure booster pumps comes down here to the engine driven pump. This is HP pumps, and then it goes to fuel filter, which is, this is it. The fuel filter, it filters the fuel, and then it comes down here to the fuel return valve. And this is also controlled by channel A, channel B, ECU. That means excessive fuel, sometimes it is applied to the engine, and it doesn't, it's not required. So it will be returned back to the fuel tanks automatically. So it will take care of it automatically. Now the fuel which comes to the fuel return valve, it goes through this pipe to the fuel oil cooler. It gets cooled, and also the fuel gets heated to prevent fuel getting frozen, because at higher altitude temperature can reach minus 60 degrees Celsius, and the water in the fuel can freeze and block basically the fuel pipeline. So it has to be heated. And engine, because it's operating and it requires oil for the bearing, it gets extremely hot. The oil gets hot, so it comes to this heat exchanger, and then basically oil gets cooled, and fuel gets heated up, and it returns back to the fuel tank. Now, here, as we had, this is the gearbox, and also this is the gearbox. This is fire loop detector down here, which is detecting any fire. It will give a signal. That's basically it is. Then we have the hydraulics. Now, hydraulics also is another thing, because flight controls are operated by the hydraulics, because it uses the muscle power of hydraulics. So hydraulics from the reservoir, which are usually installed in the wheel well, then it is supplied down here. It goes to the engine-driven pump, hydraulic engine-driven pump. Then it comes down here through this pipeline. Then basically the hydraulics gets pressurized. It goes through a filter, and then basically it goes to the actuators to operate flight controls, services, and so on. Now this is oil tank. Here you can manually see how much oil is in the tank, and also the oil quantity transmitter is also located. This will give the information in the cockpit how much oil quantity it is. If it's below certain limit, it can cause engine damage. So we have here limit, maximum, and then minimum. Now maximum, if your oil fillet is not good, and also if there is no oil, it can damage the oil bearings and engine failure. And that's basically a simple explanation about the CFM 56. Down here, somebody might ask, what is this? This is a variable bleed valve. It's like a valve. It will open to basically allow the excessive air in the compressor to bleed, basically, so that it can prevent engine stall. Technically, they say engine stall. And then we have variable stator valves, which are there over there, and they basically operate to prevent also engine stall. And they are all operated by the fuel muscle pressure, and they are all controlled by these computers, which are very expensive. Maybe it costs about $3 million US. This is simple explanations for people who are interested about aviation. Thank you so much. Dr. Javad Behbahani with you. Thank you. Bye-bye.